Hi everyone. Back to chapter 3. I'm going to run through a somewhat more complicated problem than the one we did in class before our exam. That was basically a beam with some simple supports. We're going to do a beam, but we're going to have a somewhat different support system. So let's draw our beam. Okay, now on this side, going to have a pin support. On this side, we're going to have a roller support, but it's going to be a little different. It's going to be at an angle. So here's our roller. Okay, roller at an angle of 30 degrees. Okay, now remember, the roller can only exert a force normal to itself. So, and we have of course we have a load on this. We'll put that over here. And we'll get the specifics of that in a minute. Okay, so right underneath this, we're going to draw the free body diagram. So let's do that here. Okay, so at A, calling this A over here, we have let's redo that. We have a Y component and we have an X component. Right, so AY, AX, this is point A, and this is going to be B over here. And so I don't forget it, let's put in our load, line that up there. And that is 2 kilonewtons. Okay, now B, right? So the force acting at B with this roller is at 30 degrees, and remember that the roller can only exert a force normal to itself. So it's going to be like this. Okay, so if we here, this is 30 degrees. This is B. Let's see. So this is the force exerted by the roller on the beam. We have a simple pin support. So the pin support does not stop rotation, but it stops translation in the X and Y directions. Okay, so dimensions. We have a dimension here, and we have a dimension here. Okay, this is 3 meters. And this is 2 meters. Okay, so drawing the free body diagram directly under the diagram just helps to figure things out, helps align things up properly. Now, this force is a vector. vectors have direction and they have magnitude. We're given the direction. So the only thing we don't have is its magnitude. So we can break it into components to figure that out. So let's start working on that. So let's sum our forces in the x direction. And we know that that has to equal 0 because this has got to be a static situation. All right. So we have AX. Let me get rid of some of these stream marks here. AX must equal BX. Those are the only two forces in the x direction. And BX equals B, the magnitude of that vector, times the sine of 30. Okay, that's our forces in the x direction. Now summing the forces in the y direction for static equilibrium in the y direction. Starting at the top, we have, so forces pushing down have to equal forces pushing up. So force pushing down is 2 kilonewtons, and that has to be balanced by AY plus BY, which is AY plus, now BY we know is B cosine 30. Okay, so now, so that's some of the forces in the x and the y direction. Now we're going to sum the moments about point B. All right, so B doesn't enter into it, right, because B goes through the point, so that doesn't create a moment. So AY times 5, that's its moment arm, and that's causing, that's trying to rotate this thing this way, right, clockwise. That has to be balanced by the 2 kilonewton force acting at 2 meters, which is trying to rotate the whole thing the other way. Okay, he's trying to rotate it this way. Now, the AX goes through point B. We're taking point B to be there. Goes through point B, so AX does not create a moment. Okay. So, let's solve this. So, let's see. From our sum of the forces in the y direction equal to 0, we know that 2 equals AY plus B cosine 30. All right, and so, oh, I forgot to solve for AY over here. All right, right here. This gives us AY. AY equals 4 over 5, 2 times 2 divided by 5, which equals 0.8 kilonewtons. Okay, so coming back here, substituting this into here, this is 0.8 kilonewtons plus B cosine 30, and can work that out and find B from that. Okay, so we have the magnitude of B So we have B completely described, right? Because we already had the direction. And now from some of the forces in the x direction, we had AX equals B sine 30. So now we know that AX must equal 1.4 sine 30. So the horizontal component of the reaction force at that pin is just going to be 0.69 kilonewtons. All right, so that's the magnitude and direction of all the forces acting on that. Okay, note that over here, we could not have had a roller because at point B, you have an x component of force. And if you don't have something to counter that, then you're going to have an acceleration in the x direction. All right, so this had to be some support that had that produced a force in the x direction. Okay. All right, we'll see you on the next one.